Thanks so much for joining us this Tuesday morning, afternoon, evening, wherever you're joining from. So I think we can go ahead and get started today. We have so much good stuff to cover. We certainly do not want to waste any time here up front. So thank you so much for joining us today for Connected Quality and Azure DevOps. So without further ado, I'm Jesslyn Stiles, Senior Content Marketing Manager here at Sembi, but today is not about me. Today is about our Sembi solution architects, Chris Feralia and John Bronner, who are the experts that are going to be taking us on this Azure DevOps journey. So Chris Feralia, has extensive experience in software engineering, technical product management, and senior QA testing roles within regulated industries, including commercial nuclear power and healthcare. Currently, he serves as solution architect for TestRail and RANORX, where he advocates for and supports teams in achieving their testing and quality assurance goals. And our other expert today is John Bronner, solution architect for our DevSecOps brands here at Sembi, including Preemptive and Kio1. He has a background in .NET and Java, and John has worked across development, infrastructure, sales engineering, and support leadership roles for his whole career. So they are very excited to dig into this here with you today. And without further ado, I will go ahead and hand the mic over to Chris to give you all a sneak peek at what we're going to cover on today's agenda.
Awesome. Yeah. Hey, thank you, Jeslyn. And obviously, thanks, John, for joining me today. I guess I'll go ahead and kick it off. For today's agenda, we're going to really talk about this kind of state of modern software delivery. And obviously, it'll be focused around both the Azure kind of ecosystem and DevOps tech stack I know many of you work in. We'll talk about challenges facing teams that adopt Azure DevOps. It's a great platform, but we know there's some shortcomings, especially in the area of both software quality and how we integrate and connect these things. We'll talk about this concept of what we're calling connected quality. You'll see how and why that makes sense. And it is a hint, it's more than just me talking about testing. We have John talking about some awesome stuff for our DevSec and security focused brands. And then also we'll talk about best practices, specifically around engineering, DevOps, and QA-centric focus for our teams around Azure specifically. That's really the theme of today. We'll get into some Q&A. We'll also kind of mix in some live demo and examples that John and I have both prepared. So hope everybody's excited. And like Jeslyn mentioned, you can add questions in the chat as we go, but we'll basically just take all those questions or as many as we can get through at the end. We won't pause halfway through just so we can get through all the material. So I'll kind of kick it off and talk about this idea of, what does the state of really modern software delivery look like? So a couple themes that you'll see, we'll mention today, I know John and I both at our roles at both Sembi and our respective Sembi products, right, see this all the time and more so increasing, right? Faster release cycles and the drive toward continuous delivery not being a nice to have. Like we absolutely have to have this as a requirement. Given all the AI generated, AI assistive code that's really just now mainstream part of development. AI forward or AI first development, as I call it, is becoming the commonplace, not just for large organizations, but even smaller smaller teams, right? Gaining that velocity is now needed both on the tooling and now this idea of connected quality to ensure and secure these complex systems across cloud, API, microservices, distributed systems. All these platforms have a growing need for what we're going to talk about, which is really connecting quality from testing now to security and really hardening. And if you're not sure what all those things are, again, we'll get into each of them today. And then regulatory compliance. Jeslyn gave me my intro. Thank you, Jeslyn, for this. I worked in a lot of highly regulated industries, and we continue to see that on the Sembi side for our customers, both current and onboarding, that it's becoming increasing expectation for platforms and how they perform for both software quality and security. And the collaboration and the lines between both development, this role of a developer, quality assurance engineer, software developer and test, operations, DevOps, DevSecOps, and security roles, the lines are being blurred and we're getting more and more collaboration between these roles. So I always like to leverage data. I know John has a lot of opinions. I do as well based on really core experience, but Sembi, we've just put out this year what we call the Software Quality Pulse Report, and I'm going to actually leverage some statistics from that because it's a great survey. If you're not sure, we'll have some resources where you can download, look at that. It's great to leverage how other teams are doing. I think Jeslyn added it to the chat, so feel free to take a look at that. But basically, we pulled 3,800 software quality, security, develop, engineering leaders, direct contributors, leadership roles, pretty diverse audience. 53% of these respondents are saying, their code on their teams, regardless of who's doing it at this point, is AI generated or AI assisted. So we know that velocity is definitely increasing, right? We know 43% of these organizations release software not only like monthly, but now weekly or faster. So almost half are releasing software at a very rapid pace. And we see that trend going up. So we know teams are generating code faster. We know it's allowing them to have more release velocity. But the interesting metric here, and we'll talk more about this, is 26%, only 26% report strong integrations now between software quality and really DevOps and really even DevSecOps workflows. At the same time, 68% now believe that we should have stronger alignment between QA and security would really provide a lot of value. So it's really identifying like what is really this gap or this hole that we're now seeing based on real evidence and a real industry standard. And this is basically it, at least from my opinion. And I think John agrees with me with this. If we're doing more than half is now AI assisted or generated, we're reaching or getting closer to 50% weekly or faster releases. These are great things. If I were a engineering director or leader and these are metrics, these are green metrics in my opinion. Nimble, fast, high velocity, high level of agility likely for these teams. But only 26% have strong integration for software testing, quality, and DevOps integration. That seems like more of a red indicator to me, right? How are we maintaining quality while moving very quickly? And that's really one of the areas that, again, John and I are going to really motivated us for both this webinar, specifically for our teams using Azure with specific kind of nuances and challenges there. So what do really some of these challenges look like? And again, these are Azure specific, and I want to talk about some of these. Now, again, some teams, I'll put my just general disclaimer, and I'm sure John will say the same. On the security and the testing side, I'm sure some teams maybe are not hitting these. I think a lot of teams may have these and maybe other ones as well. So it's not inclusive, but I think that these are ones that we commonly talk about for both our existing customers and those that are onboarding to Sembi products. And we wanted to share them. So one of the things here, first off, this is not a webinar that John and I want to say that, Azure DevOps is a terrible tool or it's not meeting requirements. I mean, Azure DevOps is an industry standard platform that really provides, in my opinion, a great foundation for planning, development, CI/CD, pipeline orchestration, repositories. There's a lot that Azure DevOps can do and that teams leverage, and it's a great platform. There's obviously other platforms as well. We're not here to tell you what to use, but I think first off, that's just kind of our position. It's definitely an industry leader right now in platform. Now, with that said, a lot of teams right now are managing multiple quality tools. Obviously, test plans and Azure have some software QA functionality integrated. We know we're increasing our AI generated code and how that works, increasing the development cycles and a lot more in specifically around AI and some of the implications and edge cases around AI, which I know John will talk about, growing security requirements. So in short, Azure DevOps is a great platform, but we know teams are managing a lot and there may be some gaps here or areas where we can improve or really create some good synergies with the right tools. So I'll take the first shot at this before I hand it over to John. So scaling really quality and traceability, in my opinion, again, this is just my experience around Azure DevOps built-in test plans and the ability to manage test cases, in my opinion, really is difficult to scale across multiple releases and teams. A while ago, I did a webinar around managing distributed teams. It's on our YouTube and some of the test drill resources. And that is even a multiplier when we have not only multiple projects, but then multiple teams and different orchestration workflows for software testing, planning, and execution. Test cases, it's hard to do really good, robust version control strategy for branching to align with how source control and projects are branched in multiple hot fixes, mainstream releases, and different iterations for how your release and source code management works, right? Test cases are duplicated a lot. I see the, Azure copy paste kind of model where it's really hard to manage a single source. And then managing requirements of DevOps tickets to then maybe duplicated test cases across releases and or branches or having aggregated views of these. It becomes more and more manual of a process, and I know teams have a hard time scaling. And really, this just provides limited visibility into progress across testing products, portfolios, maybe multiple releases, and release decisions. They get kind of skewed, and the evidence for what quality looks like is now across multiple sources. And really, where does that really impact the business? And I'll call kind of the engine as software quality or DevOps process. Basically, we're duplicating test assets. We're really increasing maintenance effort for not just the software QA folks, could be the developers that are helping, really across the team. Traceability is inconsistent. It helps whenever you have good traceability to support audits, but this also for highly regulated and high compliant customers and end users. It creates inconsistent traceability and puts us in a bad spot come audit time and really just reduces our release confidence. So that's kind of a common theme and challenge I see in the DevOps side around testing and integration. And one just quick example, I won't go through all of this, is really a visual around using kind of Azure-based test plans where, we may create test cases for a release. Maybe we have multiple releases happening and we have to change test cases. So I see this common pattern, as I mentioned, of we're copying from a base test case, we're pasting, we're recreating, we're duplicating as multiple release branches, maybe a hot fix and a main, point release is coming out. And we're doing this duplication, losing linkage from original requirements and a lot of effort. So lost traceability, we're duplicating these assets and really high maintenance, it becomes really hard to manage these. So I just wanted to point out that is really a very common workflow scenario. So I'll turn it over to John to talk more about security and kind of get into the deep dive areas where teams are really struggling. And I know you got a lot of good stuff to talk about, John. So
Hey, thanks, Chris. So, uh, similar to what Chris was talking about a bit earlier, what are some of the common challenges that we face when securing our releases in Azure DevOps specifically? But some of these are a bit more general. So the first I'd say is, how do I identify security vulnerabilities during development and not after deployment? So we categorize software vulnerabilities in terms of CVEs and CWEs. CVEs, common vulnerabilities and exposures, and CWEs, common weaknesses and enumerations. So CWEs are, think of like categories of vulnerabilities: SQL injection, cross-site scripting, buffer overflow. And CVEs are specific vendor platform versions. And to put things in perspective, we have today, up to today, we're dealing with over 600 such CWEs, so categories of software vulnerabilities, and we're dealing with close to 350,000 CVEs. So these are known issues, platform vendor version, out in production. So it's really unrealistic to think that you can manually uncover vulnerabilities. It's just not something that we can do. No matter how much you know about software security, specific vulnerabilities, how they originate, you just can't know it. You can't know the history. You can't take all that in and do it manually. And then add to that what Chris was talking about earlier, the sheer volume of AI generated code. So that is accelerating code generation, but it also accelerates vulnerabilities. As we know, AI generated code is subject to hallucinations. It can just give out and out, give you bad information. And similar to the first point, not a lot of developers with a security mindset would go back to this snippet or section or class or method of generated code and say, wait a minute, this might incur a buffer overflow or some type of an injection. In most instances, will take the code that's generated, plop it in there, accept it. And the only way for the generated code to get better is if we as humans in the loop take security and do it. So a lot of these things are really not realistic to ask of our development teams. So we need to kind of rely on tooling. Similar to vulnerabilities, we need to think about the software supply chain, which is those open source and third-party components. And depending on what statistic you listen to, up to 80% of the software that we deliver is comprised of these open source and third-party components. So whether it's our code or third-party code, with third-party, we have things like Log4Shell, Heartbleed, SolarWinds, things like that are built into because we have these reliances on dependencies, we have to have some way of knowing how to secure that software supply chain. It's unrealistic for us to think with everything else have going on in our heads that we might know about all the vulnerabilities that might exist in a certain package before we incorporate it in our release. And then how do we analyze our pull requests and builds for OWASP, CWE? How do we adhere to compliance requirements without a bunch of manual effort? Again, how many of us know offhand what our compliance requirements are? Do we have to adhere to OWASP or PCI DSS or HIPAA? Or is it just a regulation if we want to operate, if we want to exist in certain markets, NIS2, DORA, GDPR, or if we just have to adhere to a certain framework such as MITRE or NIST. It's really not realistic to think that we just know offhand all these rules and regulations as we're building our code or as our coding assistant is giving us code. It's not realistic. And do we have the compliance ready reports? Are those no? This is where we need to fall back a little bit on tooling and then reducing that security debt before we reach production. So how do we understand, quantify, and accept risk? There is going to be a certain amount of risk involved in going into production. That's just reality. But we need to somehow quantify that again for not just for compliance, but for our own understanding of where we're working. What is the business impact if we don't address these concerns? Security vulnerabilities discovered later in the release cycle. Who's willing to push release dates because they found a vulnerability in code later on? That's not something that anybody wants to do, specifically for notwithstanding a blocker bug, but a security issue. Vulnerable code that's exposed after deployment. You didn't find it, it's exposed, it's exploitable in production. Zero-day exploits coming from the software supply chain. Manual security reviews, again, those are error prone. And then limited visibility into the overall risk. If we're not maintaining that compliance, what are the fines for, are we going to lose customers? What is the risk of non-compliance? So these are all things we need to consider as we're building the software. Then we have to think about how to secure those releases after deployment. So once we go into production, so we've done everything that we could before pushing our code out the door. Now it's in production. It's in our customer and end user environments. So how do we know that that is protected and hardened against reverse engineering? Have we added appropriate, effective, standard mitigating controls? Don't roll your own crypto. Don't even try it. It's like that's the old saying. Just you need to go with standardized mitigating controls. And then how do we mitigate the risk from running in an untrusted environment? The fact is, a mobile device, or if we have a turnkey solution that's running on our end user's cloud environment, or even on their desktop, that is an untrusted environment. That in and of itself brings its own level of risk. So again, and then if we don't address these challenges, we have the risk of sensitive code exposed after deployment, reverse engineering of those apps. We might risk IP theft, software piracy, counterfeiting of our apps. That's quite common these days. And then the apps are basically a conduit for our data. There might be theft of our customer data, probing for vulnerabilities. So reverse engineering could be used to probe for vulnerabilities. It could be used to launch a denial of service. That's just an example, but there's one of a plethora of things that could be done just from those binaries that we have in production. So what's the solution? The solution is to make sure that we're integrating our security into the software development lifecycle. In this case, namely Azure DevOps, but if we're using Jenkins or Circle CI or Bitbucket as our software deployment platform of choice, all these things apply. So any type of security that we integrate, it has to be able to occur simultaneously with all other aspects of our software development. We can't just stop everything in order to apply a new security tool. It just doesn't work that way. So SAST is our static application security testing, and that's where we're analyzing source code to identify and remediate those security vulnerabilities before it's even compiled. So you don't need a compilable product. You don't need to set up a demo environment like some of the other security scanning tools. SAST works if you have 10 lines of code or a million lines of code, you can scan that for vulnerabilities and address those right away. With SAST, we can do things like not only integrate into our CI/CD, but we'll see later in the demo, we can add security gates. So instead of running a full scan, we can define those criteria for an acceptable build. Like maybe we can't accept any new OWASP top 10 vulnerabilities. If we do that, I want to fail the build. Or something from NIST, or something from MITRE framework, or one of the other compliance things. We can put those security gates in, full compliance ready reporting, all that is built in. SCA, the other side of the spectrum where we're identifying and managing risk from those third party and open source components, also known as our software supply chain. All that occurs before having a distributable even for our product. And then on the flip side of that, with preemptive, so no matter how free our software is from vulnerabilities and flaws, we're still susceptible to reverse engineering and tampering once in production. So do our level best to eliminate those vulnerabilities in code. And then once the binary or distributable is out in production, it's out of our hands, it's in an untrusted environment. Well, then we need to have something like obfuscation and RASP, obfuscation to prevent reverse engineering of those binaries and distributables. So trade secrets, API keys, API endpoints, all this type of stuff is built into that distributable. It's living on our website. It's running in the browser. It's on the cloud. It's on our mobile device. So obfuscation, it combats decompilers, disassemblers, string analyzers on our distributable. And then we have RASP, runtime application self-protection, built-in protection against compromised modes and compromised environments that our software would run in. So that's anti-tampering, that's code integrity, that's anti-debugging. So after you deploy that software, nobody should be trying to run a debugger and see the data flowing through your app. And then root detection. So is somebody trying to run on a compromised device or use Frida to, again, watch the data going through our app. And to tie this in back all together, so with Keyoon, we have the SAST and SCA. With preemptive, we have obfuscation and RASP. I think there's a tendency to think of like a bug as just erroneous functionality. So functionality not matching spec and a security vulnerability being a totally separate thing. But in reality, a security vulnerability is just a bug. It's just a flaw in code or configuration that a bad actor can then use to compromise the system's confidentiality, integrity, or availability. So it gets the software to behave in a way that it's not intended but by the original intent of that software. So it's just, we think of like a bug that's not discovered in the QE phase as something that will get uncovered by a customer. We'll have an angry customer, we'll have a bug report, that sort of thing. But a security vulnerability all it is a bug. It is a bug that if it's not uncovered, then it has the potential of turning into a data breach, data theft, software piracy, all these other things. So again, Chris and I have talked about this in some of our past sort of webinars, but there is that strong connection between quality and security where we can't consider our software to be a quality product if we have security vulnerabilities. So yeah, that about ties that up. So I'm gonna hand it back to you, Chris. Thanks.
Awesome. Yeah, great stuff, John. That's a great point to segue. I'm going to go and share my screen. So, John, we mentioned there's going to be a live portion. So, John and I have kind of both prepared both on the testing, and then John will a demo, and then I'll transition this after mine to John to really go into the topics for both security and hardening, really the themes of the webinar today. So, I'm going to go and share my screen. And I'm hoping this will generate some questions, but like I mentioned, we'll be kind of getting to those at the end. This way we can get through the content. Hopefully everybody can see my screen. So I want to talk about briefly what we're providing. One of the core areas, we just released it actually, and we'll have some resources at the end or in the chat. So TestRail has produced and actually just recently released for the Visual Studio kind of Azure marketplace, as you see, the TestRail for Azure DevOps. It's a free app. And that's what I'm going to show that really highlights the ability now for those that use TestRail currently. Hopefully, we have some of our existing TestRail users, or maybe some curious to investigate or maybe do some trials. Essentially, what we're going to show is the TestRail app. We have some full supported docs for that. We can share that as well, and kind of how that configures. These are all online and available if you're curious what it looks like. But basically what I've done is, this is my TestRail instance. For those that are not familiar with TestRail, we really have some core entities in TestRail. We basically have test cases with various project types and the ability to branch and source control on these test cases. Then we basically have the execution of the test case in essentially what we call a run or result or a test case execution. So not going to deep dive too much into that, but what I've done is I've installed inside of my Azure DevOps instance our TestRail based app for specifically the purposes of not only traceability but execution, linkage, and really for productivity. So one of the ways we can start to leverage this idea of enhanced traceability for existing tests, you use TestRail to actually leverage your test case repository. So for instance, I have a test case here that it's a very generic one, just called valid login. This is my sandbox. I've linked two different reference requirements, reference 1 and 2, and these are actually Azure-based requirements from Azure. So these are DevOps work items. And we have the ability to link these both in real time and also create them if we need to now directly from TestRail. So, if I edit my test case, I have the ability to actually launch and add new requirements specifically from my Azure DevOps instance. So you'll see it's redirecting. And I can add those directly from TestRail and then link them. If I have existing ones, which I've already linked, this is your reference requirements 1 and 2, this builds our traceability model for existing Azure DevOps work items that I now can tie back to my test cases. So we're building good traceability across the version history for a given test case. So you'll notice here we can modify, change, or revert history tracking across versions, and you'll notice any changes in these requirements, we actually track test case to test case. So this provides significantly increased enhancements based on just standard Azure test plans versus real strategy for branching, version control, and traceability to your Azure DevOps work items from a test case perspective. Now, obviously, these may be manual test cases, so that's obviously one area. We also handle that for automation that I'll talk about in a moment. So once we have that, a lot of teams now may want to go and actually initiate these artifact creation directly from Azure, right? So if we go to our Azure board, I've created a couple work items, and maybe, for instance, like adding CAPTCHA to a login portal. Well, the TestRail plugin, as we start to link TestRail test cases, maybe executions in runs, actually adds a specific panel section. You can move this orientation around in your inherited preferences for Azure on how your DevOps kind of templates work. But you'll notice here that it links one of our test cases, valid login, that I just showed. We also can demo and show different areas that these are being used both in executions and runs, which we'll show in a minute. So, for instance, if we're on an Azure DevOps work item, from a productivity perspective, you actually can initiate adding test cases directly from Azure DevOps directly into TestRail. So it'll actually ask you, and I have a bunch of different projects. So for instance, here's our DevOps master. We talked about branching and version control in TestRail. We select where we want it to go, and we can actually go and redirect and now add and automatically associate that reference to the test case that we're going to create. So it's not only a way we can take existing items, but we also can use this for productivity for teams that want to be in DevOps create new test cases, in this case, more manual verification, automatically link and create in test trail. And then, as I mentioned, that these tickets in these test cases to work items or tickets in DevOps will automatically propagate and build a good traceability model. So we know the capability for both test cases existing and new, but what does it look like if we want to actually go and add these for execution? So you'll notice here in test trail, and I won't go into some of all the test trail details. We'll have resources if you're curious on some more of these native test trail features, but I've created a test plan that executes some test cases on two different configurations for browsers. These are just my login test cases for both Chrome and Safari. Maybe I have another test case down here as like a smoke test run. I have the ability to also include on my test planning reference requirements from Azure DevOps as well. So you'll notice I have our two tickets that maybe implement this login, have two requirements that I've added to those. I can click on them if I want. I already have one of them opened. And you'll notice here that I also have another menu that says test trail results. So I can actually expand that. And I can actually go to these results and maybe during defect triage, maybe during our product-based review or reviewing release scope, any Azure DevOps work item that's linked now, for instance, if I want to see if it's integrated into my test planning, my run execution, you'll notice this shows that this adding just a CAPTCHA to the login portal, which is just my sample kind of workflow demo here. You'll notice it's referenced on multiple test runs in test trail. It shows us our pass fail ratios and any ratio of test automation that's been failed. These are all manual test cases. And I can actually now click these, and with my test trail authentication, it directly takes me to these items, really creating a seamless now work integration between both Azure and test trail across the SDLC. These are both runs, plans, executions, run history, and requirements. So that's kind of covers a lot of what I've talked about, but I want to mention also the other half, or really part of combined strategy, which is automation and really pipeline orchestration. How are we able to now integrate this level of traceability from an automated perspective? These are traditionally manual workflows. So I want to go in my Azure, my DevOps instance, and what I've done is I've created a very basic Azure pipeline here. I have a repository that actually runs a Cypress-based UI automation. So teams maybe run Cypress, Playwright's very common now. Really doesn't matter what framework you're using, but we basically have configured and I've set up an actual pipeline execution YAML file that takes the execution from our Cypress tests, and it includes the ability using our test trail Python-based CLI. You'll notice we have kind of a scripting target or script job step here or block that executes and installs Python and takes the results from our JUnit-based output from automation and actually automatically both creates, and now in this case we have the option of linking our requirements directly to these Azure work items. I'm doing this programmatically using an actual environment variable. So teams in this test run references can pass a comma separated list, just like we did manually, of our Azure requirements to any type of automated test execution running from a pipeline. And what that looks like, so I'll show you, I'm not going to run the pipeline. I've already run this just from a time perspective, is you'll see here my completed job and job stage steps where we do some installation commands, we set up Python, we execute our Cypress tests, so we have some passing and failing Cypress tests, and then we now go and upload our Cypress automation results automatically using our test trail Python-based CLI. So you'll see our CLI gets invoked. And note that it actually identifies 3 different Azure requirement references to Azure work items, and it adds and automatically now associates these to the test cases that are now generated and linked via automation. So that basically now has the Azure requirements associated to the run execution of this automated test run. So if we go to that, you'll see it here. It's the top one. It's Cypress automated tests run from our Azure pipeline. And if we click on this, This gives us an execution of test cases automatically mapped and created. That's with our test real CLI. And again, if you're curious what that is, well, more information. We've done a lot of CLI focused videos as well. You'll also notice we have a link. So if I click this link, it takes us directly to the pipeline that's created. So we know where it came from. And each one of these is now in run executed, and now we have our Azure references automatically now linked to each one of the work items. And then obviously these now align if we go to the actual executions, right? We can actually see here's our release regression or our automated Cypress execution now using our Azure-based plugin. So we're building traceability from manual to automated testing. We're leveraging in that programmatically in our pipelines, and it builds a really great traceability model that we can do across the SDLC, whether it's unit tests, Cypress-based integration, whether it's API testing. And whenever we run this, I've actually set up this pipeline to take a parameter. So those run references, so if I wanted to maybe run a new one, if I go and click run, oh, hold on one second. I wanted to show you before I did that. So if I actually go ahead and execute this, let me go back to my pipelines. If I go and run this, before I run this, it gives me an option to actually identify the value for my Azure work item variable. So if I want to manually add, or I can do it via API or scripting, but this is a user variable that we can modify prior to pipeline execution to tag any Azure work items if you're maybe running this on demand for like a regression set. Or again, you can do this programmatically and orchestrate however you like. So in short, I think the big takeaway here is we offer some additional tooling both on the test management side, in addition to, and I'm not demoing this, but I want to highlight, Ranorex as our low-code, no-code automation tool offers an additional pipeline execution for those running Azure DevOps server, where you can essentially take your Ranorex low-code, no-code automation and directly plug that in and have basically a runnable step plugin to manage these executions. So if you're running open source, integrating through TestRail that way, if you're running your Ranorex suite for those teams that are looking for the low-code, no-code options, or already run Ranorex, we also have an Azure-based app where you can orchestrate through both either TestRail or execute your Ranorex suites. And these things will really build not only manual, but automated integration and bringing these things together to really build traceability that scales from an Azure perspective. So with that said, I want to pass it to John. This really covers the first kind of pillar, which is testing. This webinar wanted to address for Azure. John's going to now talk about that idea of security, scanning, and now hardening in the Azure ecosystem. So I'll let you take it away, John.
All right, thanks, Chris. Yes, Chris has covered the TestRail Azure DevOps extension. So here we'll take a look at a pipeline with our free QUON and our free preemptive Azure DevOps Marketplace extension. So we'll just take a look at those two very quickly. And so what we have here is an Azure DevOps project for a standard .NET utility application called PinUtil. .NET, Azure DevOps, hand in glove. So this is a .NET project, although a lot of the concepts that we presented are applicable to basically any build, deployment, and CI/CD tool of choice. So for this project, I have two pipelines set up that we're going to take a quick look at. We have an Azure DevOps classic pipeline with a QUON baseline analysis. So we'll be using QUON for our SAST and SCA scanning. And then we have one Azure DevOps pipeline with a YAML configuration, so probably more common is a YAML configuration, and a QUON delivery analysis. So a delivery analysis, as opposed to a full security scan telling me, hey, what are all my vulnerabilities? Show them to me, help me remediate them. A delivery analysis allows me to set security gates, and I can pass and fail my build based on a certain set of criterion. And then I also have a obfuscator for hardening in this pipeline as well. So let's take a quick look at the configuration real quick. Again, this is the classic pipeline. I don't imagine many of us are using a classic pipeline setup, but nonetheless, here it is. So in our pipeline, we have a Key1 baseline analysis, so we've run, we'll before compiling we'll build our solution, then we'll scan our code for any security vulnerabilities. And we'll also do an insights analysis and upload source code fragments for defects found. So Key1 will scan the source code repository for any security vulnerabilities, report those to us, help us fix them. And then Obfuscator will help harden the binary artifacts of this project. So DLLs, executables, how to harden them before deploying them to our end users. So if I go back to a run of this classic pipeline, I noticed that when this was built, a Key1 tab would be spawned, and I'll get an overview of a security summary and a quality summary. So after scanning this code, I have one very high vulnerability, which knocks me down to a 1-star security rating. So bird's eye view of that. And then quality, I see some quality indicators here. My risk index, which is actually pretty low, that's not too bad. And quality indicator, so whatever indicators I've set for acceptable quality, it will take me approximately 5 hours to achieve that quality indicator target. So security, we're scanning for security, code quality, and then third-party vulnerabilities. So if I wanted to see the details of this, I could then pop out to the Key1 portal. Obviously, I'd have to authenticate. But if I want to get more detail, so let's say I want to see what this very high vulnerability is actually that the Key1 scan found, I then get all the details that I needed, the line number, and then everything I need to go ahead and remediate this vulnerability from the Key1 scan. And again, that being a baseline scan, so it's going to give us all the details. And then also in this scan, I had produced, I had run Obfuscator to harden the artifact. So if I look at what has been published, gone ahead and downloaded this drop previously just to save a little bit of time. So if I look at the original binaries that are produced by this build, and I could go over to a freely available decompiler tool called ILSpy. If I were to do nothing in the way of hardening, I could take my executable and any DLL files right into the decompiler tool, and then boom, I can get right to this project, the pinutils main method, load up the main form, and then just by a little bit of peeking around, I found this tool's activation mechanism. So just as an example, this could be in a real world app, this might be an API key, any sensitive endpoints, anything that's built into our distributable. This could be a mobile app, it could be something in cloud. If we do no sort of hardening, then our app and our source code is exposed. This could be IP, this could be anything that we really don't want to get out there in the open. So by applying Obfuscator to this build, if I look at my drop, I have a Obfuscated directory. Normally we copy this to where we would deploy it, and then I try and do the same exercise. I would see that that code is obfuscated. So I can no longer see, hey, this is my licensing activation mechanism, and here's how I would find that endpoint, potentially tamper with this code, potentially modify this code. So I could modify this binary in place without having to decompile and recompile. I can do that. The tooling is available to the hackers. I know I protected this by applying the code obfuscation. So those are the two steps that we ran in our classic pipeline. And then just really quickly to finish this out, running a Key1 delivery analysis. Again, probably most of us are using YAML-based configuration. Similar thing translated to YAML, Key1 delivery analysis, and Obfuscator's command line. We just set it right in our pipeline's YAML. And then because this is a delivery analysis, I can set the criteria for an acceptable build. So as opposed to running a full scan, getting my full report from Key1, I can set a Key1 audit, which in this case it failed because the checkpoint that I set, which is no new defects, was not passed. So wait a minute. Uh-oh, there's a new defect that was somehow introduced in this build. If I want to investigate further, create Jira tickets, whatever, based on this failure, I could pop out to the Q1 portal. No new defects, has failed. Uh-oh, insecure transport. I get all the details I need to fix. Oh yes, in that activation mechanism, I'm not using HTTPS, head slap right there. So again, we run into this type of stuff with generated code, but as long as we have the right type of tooling in place, we can then catch that as part of our build. Q1 found it for us, halted our build, and then it'll allow us to address this as a part of our regular process. So again, from Q1, I could kick that out to a Jira ticket and then fix that in the next sprint. That about does it for my portion here. We've seen two different renditions of what we did for Q1 full scan, and then Q1 setting those gated checkpoints in our build. With preemptive, in both instances, we hardened the binaries, and we saw how if we don't do anything to harden against reverse engineering, we might be in trouble with reverse engineering. So, but yeah, there you have it.
Thanks so much, John. Looks like we're going to hand it over to Chris to cover our takeaways, and then we can get into our remaining time for Q&A.
Yeah, great stuff, John. And really, like I said, that kind of brings, and I hope it helps everybody to go really the idea from testing, kind of what I talked about in the test side with our new Azure-based plugin, traceability, that integration. I mentioned briefly about Ranorex and those teams looking for no-code, low-code solutions, or those that already have it, a mechanism to reliably and quickly just integrate and then run automation as part of pipeline orchestration and link back to maybe test management. And then John with some great stuff on again, the security, SAS scanning, and then really hardening using preemptive is it's a great tool with the plugins for both preemptive and Q1. So really our top five takeaways, and before we jump into questions, are, really deliver quality, not just code. We gave everybody on this call, I think, on this webinar, really some great understanding of it's more than just pumping code out. It's more than just a quick sanity check. And Azure-based support from a Sembi perspective on both TestRail, Ranorex, Key1, and Preemptive provide a lot of options for that, the Azure perspective, specifically in DevOps. In really doing that from an end-to-end traceability perspective, right? Connect those requirements, testing, and releases. And it's really, really important to know where your gaps are, and that gives you the ability to identify those. The third one here, I think John talked about really showed the most, is this idea of shifting security left, where we don't want to wait till we're in production to identify issues, known vulnerabilities, or to find out that we've not hardened our deliverables, which now can be tampered or exploited. And again, Key1 and Preemptive, the demo, John just shows a great example of that and how it doesn't take much to achieve good quality through security. But we have to be mindful to do it and have the tools to get us there. And then fourth is we have the ability really to extend Azure DevOps with these integrated automated quality solutions and security solutions, both with plugins, with tooling, and orchestration, and using all the good features that Azure environment has, right? The great ability to link repositories, leverage and run pipelines. You can create very robust YAML orchestrated Azure pipelines, parameters. I showed an example of that, both with the runtime parameters, some mask parameters, and you obviously can inject and build scripting how is needed to achieve these things, these workflows. And then lastly is releasing with confidence, right? Getting more connected quality and insights both through tooling and good process, I think is what John really and I really wanted to double down on today. So hopefully that gave you that. I'll transition it. We'll just jump it right to questions if you want to use the Q&A box. And we'll also look at some resources. So while we're asking questions, thanks, Jeslyn, for putting that up. All of the actual Azure-based downloads and marketplace apps are free. If you don't have any licensing for these tools, we have free trials available. So we'll leave that up. Anybody's curious based on some of the process and workflows John and I demoed with these, to take a look. In the meantime, if anybody has any questions, feel free to enter that in the Q&A. We have a few minutes left.
Yeah, thanks so much, Chris. I'm just going to leave this slide up here while we're doing Q&A. You can scan the QR codes to get to the download. I'm also going to put the links in the chat, and then of course we will also include the links in our follow-up. So we're going to make sure you have the links to download one way or another, but wanted to leave them up here in case you wanted to check them out while we're chatting. But in our last couple minutes here, I see a few anonymous questions in the Q&A that I'll throw out here for you guys. First and foremost, which I think is a great one to start with, is how easy is the installation for these plugins?
I think we'll both take it. I'll take this first, and then John, you can talk about on the security side. So from a test-drill perspective, we do have an actual installation guide on our support docs. It's basically as easy as going to Visual Studio, Azure-based Marketplace. You can just search in the top box, test-drill. You click install, and it's very easy. It'll install it in your instance. It's a codeless installation configuration, meaning all you need to do is install it. You configure it in your Testral admin section. We have all the online docs available, and then you can start using it with all of your Azure work items like I showed earlier. So pretty straightforward. And the same with Ranorex as well for those that run Azure Server. Essentially takes an exe and executable, which is your Ranorex run artifact, and you can basically add it, configure it, point it to your artifacts, and run those as part of your pipeline processes. I don't know if you
Great.
want to talk about key one or preemptive, John, if you want to cover those.
Yeah, so the same story for Key1 preemptive, very easy to set up. Whether you are using the classic pipeline configuration or YAML-based configuration, we have the plugin that'll work with both. It has all the configuration parameters that you would need to run both tools. So getting up and running, probably just run the defaults because both tools, Key1 and preemptive, have full granular controls. So first project has, you have two DLLs, two binaries, 50, 100, 1,000, whatever that you're trying to harden. The same side of the story with the same story with Key1. You have 500,000 lines of code, 1 million lines of code, 10 million lines of code. So the tools are very configurable, but we also have very reasonable defaults. So out of the box, you can get up and running, run with the basic defaults, and then configure it. It might take you a sprint or two, but yeah, and similar to what Chris was saying about TestRail and Ranorex, we have full documentation. All of our documentation is public, but for those fine-tuning those dials, all that's available as well.
Great. Thanks, guys. Another anonymous question here. What if I want to trial these plugins and don't have a TestRail or Key1 or Ranorex or preemptive license?
Yeah, I think we already covered that, and I know we just have a few more minutes left. I'll just say, I think we'll put information, maybe Jocelyn, on how to both navigate and maybe trials, but these plugins are all free. If you don't have licensing for the corresponding tools, whether it be Obfuscator for preemptive or TestRail in this case, we have free trials across the board for all of these, for any of the stuff that John and I showed. So
Yes,
we
we'll certainly
encourage
follow up
everybody to
with
get,
that.
yeah, take a look at the resources and feel free to trial or engage as needed. We have a lot of resources for everybody.
Awesome. I just saw one come through in the Q&A here. Can TestRail connect to Azure DevOps via REST APIs or plugins to sync test cases, results, and requirements?
Yeah, great question. So TestRail CLI is what I use today. And essentially, TestRail CLI is one way. We do have a full RESTful API for TestRail-based integrations. So you can leverage a combination, one or the other, of both either the CLI or our RESTful API, in addition to our supported Azure integration that I demoed today, along with the actual plugin. So it could be a combination of all of them in alignment with what you want to achieve with ADO. So good question. The answer is we have all of the above available to both sync real-time, legacy, or via the Marketplace app.
Great, thank you.
I think we have one more actually by Srikanth. So can we trigger test trail runs directly from ADO pipelines using custom scripts or extensions. We definitely have that capability. You can utilize API-based integration with Azure. Um, so if you want to trigger using a TestRail UI script from a button or a custom button, we have resources where we have customers that do that, usually via API. We also have a MCP beta coming. So we have some beta in beta currently, but we have MCP capability coming for TestRail. And you also could leverage once available MCP-based capability for both TestRail to Azure MCP if you want to do more agentic orchestration. So a lot of current state and future capabilities for that. Great
Great.
questions.
Yeah, thanks so much, Chris. We are at top of the hour. Chris, you can see these anonymous questions. Were there any other ones you wanted to answer or touch on here in our final seconds before we sign off, or you think we're good?
I don't think I think we're good. We're right at time. I'll just let everybody know. Feel free to follow up with any questions for John and I. Appreciate the engagement, and we have a lot of reference resources. Feel free to take a look at those. And again, we're happy to support any trials or Azure-based questions specifically if anybody has any um, difficulty or wants to do deeper integrations.
Great. Thanks so much, Chris. We will be following up in a couple days with the recording, all the presented resources, all the great resources that Chris mentioned. And yeah, we hope to see you all again soon. Thanks so much for joining us on your Tuesday. Take care.
Everyone.